Okay, I'm going to talk about ground gas protection, and it's only as good as its installation and the role of verification. It's a very evocative subject at the moment, so there's about 40 million slides and I've got to get them in 15 minutes, so it's going to be quick. Oh, it's not letting me move. Oh, there we go. So we go, sorry. So this presentation is an introduction into current practice in regards of radon protection in just house construction I'm sticking with. So it's really relevant to large developments, 100 houses, 150 houses, and right down to the single builder. So it'll cover installation from the inception to the project completion and the issues associated with the construction phase. Sorry, I'm just trying to work out the button there. So radon, we've had this already, 1,100 deaths. Should we take this seriously? From where I look at it, you know, I've been involved in ground gas, carbon dioxide, methane for 5 years. And this figure hasn't changed for 5 years. It's always been 1,100 deaths for 5 years. So to me, if I was looking at that, well, it hasn't really improved. We're not really doing anything better. Again, you've seen this. Now, how I look at this, we've got accidents at work. Well, we've got the Health and Safety at Work Act. So, and that has less deaths. We've got drink driving. Well, it's plastered all over our television adverts, etc., etc. So lung cancer from radon at home, I think you could potentially have a word with most construction managers and they don't have a clue what you're talking about, which is a little bit worrying. Consequences. It's obvious what the consequences are. Currently in the housing sector, I would definitely say the industry tends to ignore radon, and I'll cover this later on. The contractor, the installer, and the buyer all tend to want to forget radon. And I would say the primary reason for this is finance, image, those two items. So current practice. Radon gas remediation systems are installed predominantly by house builders and their subcontractors, either bricklayers or groundworkers, who have no knowledge of the ramifications of poor install. This lack of knowledge extends from senior management right down to the installer. Again, down to education. A lot of house builders think they're building a brand new house. Their house is fantastic. It's a new house, so it must protect the occupants against radon. It's the other way around. New houses are air tested. They are 100% airtight. Whereas old houses, you know, they leak like a sieve in a lot of cases. They don't have double glazing, or the double glazing they have are timber framed. So, you know, they have that misconception. They think they are doing a good job, but not necessarily. Awareness. Now, I saw this a couple of weeks ago. So, you know, it is out there. The world does know about it. If the Simpsons and the cartoon character know about it, then yeah. I saw this a couple of years ago in Switzerland, and I thought this was great. So what we've got here is this was a lady's basement. She was adamant there was no radon. She couldn't see it. She couldn't smell it. So these guys decided, right, okay, we're going to build this chamber to show her the potential risk that was relating to radon. So she can now visually see it. So there is, you know, if you can see something, then great. With carbon dioxide and methane, which I'm primarily involved with, there are results from it. It'll blow up or you can't breathe. With radon, it takes so long. And this visual thing I thought was fantastic, fantastic thing. Oops, if I can move on. There we go. So, no radon protection, not 3%, but however, it is recommended you do a radon test. Basic radon, 3 to 10%. Now that's a membrane. Now, BR211 recommends 1200 gauge. Well, I'm afraid if you walk on a 1200 gauge, there's a good chance you'll damage it. They typically come folded, and they treat them like damp-proof membranes. The BVA has got involved, and that has increased to 0.4, which is a much more robust membrane, which is much better, much better. NHBC, they've embraced this scenario because they expect all their products to be BVA accredited. Now, full radon protection, membrane and venting. This can be radon sumps, ventilated subfloor voids, or even 25mm vent mat. Again, it is recommended that a 3-month rating test is completed, and so this aids the homeowner and also proves that the radon design is successful. However, this was pointed out earlier on. They may get this information, the information may be collated by the house builder, but what does he do with it? He tends not to do anything with it because he's afraid that it may affect his sales, or the application is poor, and this is going to cost him money. So yes, we've done numerous sites where we've done this, and they've not given the information to the homeowner. Now, this is pretty good information for the homeowner, because if he wants to sell, he's got that information there. Sorry, I can't find. So good installation and verification versus existing radon membrane installation strategy. So good practice is good radon design, specialist installation, verification, and that leads to robust proactive protection. Typical good design, block and beam. This is typically what we build in England, not necessarily Scotland, but in England we have block and beam, good ventilated void, good ventilation, so good air change per day, and then we have a membrane going over the top. Fantastic, great design. Radon sumps, as long as radon sumps are designed correctly, so all the areas are interlinked, then that's good. Professional installation by a specialist company. If it looks right, it is right. In most cases, you can see that all the internal corners, all the external corners, all the pipe penetrations look identical. A specialist installer can deal with these particular instances for houses. We have doorways, internal corners, external corners. Now, pipe penetrations for housing typically occur in the corners, the soil and vent pipes. Now, you cannot use a preformed top hat in these scenarios. They're too close to the wall. So you need a professional who understands this. When you get a different change in level, the photograph on the left there, I mean, that is very, very good. I've got a little video here, if it can play, that shows just a brief insight into professional installation and the procedures that they go through. Typically, the advantages of this, of a professional doing this and a specialist, is that typically a plot this size will take about an hour and a half, 2 hours maximum, even for one guy. A ground worker will take typically half a day, 3/4 of a day to do this, and then predominantly not very well anyway. You can see they prepare the substrate correctly. They prepare the laps correctly, so they've got the correct lap of 100mm or to the manufacturer's specification. Here you can see what they're going to do is they're going to do some hand welding. So the joint is done correctly. You can see here, this could be taped or welded. Then we go on to the correct detailing of pipe penetrations using a gas resistant self-adhesive. Normally with a ground worker, what they'll do is cut a big hole, and that's your detail. So what they're doing here, nicely detailing round, and then we get the verifier to come in, and he typically will use various methods. Here we're doing an air lance testing, 50 psi. Here we're doing pick and probe, so all the laps are tested for robustness there. And there you go. So that is a very, very quick methodology going forward. Specialists know how to weld. Specialists know how to tape. Now, people think taping is straightforward. You have to roll the butyl tape so all the pops come out. Venting. 25mm vent mat is becoming more prevalent in the industry. Now, ground workers don't even know which way it should go up. There is a fleece underneath there. Often as not, we will see that the other way around. So verification. Any ground gas protection system is only as good as the design and installation. We have good guidance in the UK, but we don't tend to follow it for radon. So we've got here BS 8485, which is primarily for carbon dioxide and methane. However, it does state radon should be considered the same as carbon dioxide. Series 735, verified. BR211. So this is radon guidance on protection for new buildings, but this does not go far enough. It should reference Series 735 because then that gives the testing and verification procedures. It's a little bit fairy, but all these lead to verification and professional installation. So what a verifier does, he will pick and probe. We could do a spark test. Now this is very, very good for radon barriers because they don't have an aluminium foil, and they can find pinpricks very, very small. Fantastic bit of kit. We also have a little video here where you can use a smoke test. Now we pump under smoke using a fan. It filters up underneath all the membrane, and where there is bad installation, you will see smoke coming through. It's a great little visual test. Good visual test for the likes of NHBC and the likes, and you can also prove to the installer what he's actually doing wrong. So, and then finally we have here the good old the good old air lancing kit going around, 50 psi, small jet of compressed air which will open up any bad lap. Now we get on to the bad side. So I've explained the importance of radon protection, but what happens? Well, due to human nature, poor workmanship. This is down to knowledge. Do we really care? Well, again, it comes down to knowledge really here. They're treating it as a DPM. Lack of knowledge again. They're treating it as a DPM because it is subcontractors such as ground workers and bricklayers. Program, well, you know, they want to get it done. We've got the Friday afternoon syndrome and the Monday morning syndrome where, you know, they want to get off. Poor design, lack of knowledge. Because it isn't specialists who are doing this and it's not being verified in most cases, they don't understand what's going wrong. Wrong materials, well, typically they'll use a 1200 gauge visqueen or a DPM, which uses recycled materials, and they take shortcuts. Bricklayer comes along, sees the radon barrier going across his cavity where he's building his bricks. What he'll do, he'll just cut it off because it makes him laying bricks, or it makes his process much slower. As I said, radon barriers, they're typically folded at the moment. Now if you leave them a while, they will revert back. They have a memory in there, and you can see it's pricked back up again. This was stood for a day, and what's happened there is it's created a direct route for radon. This poor old guy, he thought he'd done a fantastic job, didn't understand what he'd done wrong, and I don't really need to explain this. All of these examples, by the way, are in the past 2 weeks. Okay, these are just 2 weeks old, so this is happening all the time. I mean, this is a fantastic one. Is this over 100 houses? They applied a radon barrier over the cavity. The bricklayers came along, cut that off, and when they built the houses, they noticed areas of damp around the doorways. They checked. They took out some blocks, then they realized that the radon barrier had been taken out. So building control were over this. What they've had to do is support the whole of the perimeter of every house using jacks, brickwork taken out, a membrane inserted in to join onto the old radon barrier, and then brickwork put back in. Now, I've had one of these a month for the last 3 months. So something wrong. We get this a lot. This is Metsec, could be timber frame for housing. The builder will put this in before we arrive. He'll say, yeah, I've got the membrane underneath the Metsec. I'll say, oh, well, okay, what about your fixings that you punch right the way through it? All right, okay, well, what can we do? Well, not a great deal, because you're going to have gas coming straight the way through the membrane that you've just punctured. Ground worker application doesn't understand design, doesn't understand the material, so you've got issues. Got the design completely wrong because the insulation should have gone on top of the membrane. So yeah, if it looks right, it is right. Classic example, ground worker installation. what you typically get with membranes are T-joints. He hasn't detailed this T-joint correctly, direct route for radon gas. This is a particular one of mine, which is really created by warranty providers, that they class the venting as the primary method of radon protection. Now, what you get typically is that being compromised by houses because they are single management structures, and they will incorporate decking, planters, and conservatories, and the differential in levels. The builder will look at this, or the drawings will show 150 mil below the air brick. However, what typically happens is they get compromised because of the build process. Now, on my estate, which I'm going to show you now, this little video, hopefully it'll work. This is my cul-de-sac, roughly about 12 houses. Okay, here. So it starts with the first house, compromised, the deck, the whole area has been covered over. We've got decking, which has covered the air bricks. Then we've got a patio area, which has covered the air bricks. Then the next one, we have decking, which has covered the air bricks. Then we move around, and we've got a conservatory. And then we have decking and a conservatory. So what we've got here is, I think it's 10 out of the 12 houses that compromise their venting. So if you don't have correctly applied membrane and verified, you're going to have an issue, potential issue. So in summary, so you understanding design requirements, increased site knowledge, better materials, better installation, verification and testing is a proactive methodology of radon protection, rather than what we've got at the moment, which is treating it like a DPM. Right, okay, let's put the DPM in. Yeah, we're not really that bothered. And okay, then we'll do a radon test, and then we've got problems, which is reactive. This is a proactive methodology. Thanks very much.